microcontrollers, wherein we will use the Keil µVision software for the development of 8051 microcontroller coding. It provides the necessary tools to write the code, compile it, then simulate and perform debugging operations. The Keil µVision provides an integrated code editor wherein you can do the programming in C language as well as assembly language. The Keil µVision software supports a built-in compiler and assembler as well as a debugger and simulator. The final output from the Keil µVision is the hexa file. This hexa file can be downloaded into the microcontroller. This editor is used to write the programs in embedded C or assembly language. So then after writing the program, you can use the compiler and assembler available inside the Keil language. So finally you can generate the machine code also from the Keil software itself. So that final machine code can be downloaded into the kit. You can have a development kit. So into the development kit you can download the hexa code, that is the code generated by compiling this code written in C language or assembly language, that can be converted into hexadecimal values. So that file will be saved with name.hex, so that you can download into the kit, whichever development board you are using, into that you can download. So all these features, that is writing the code, then compiling, assembling, and finally even downloading into the kit, that can be done using the Keil software. So for this reason, this Keil is called as integrated development environment, and that is the recommended software which I would suggest for students doing project in 8051 or other embedded controllers related to Atmel company. And once the code is compiled, you can also do some more processing, such as you can simulate the outputs and see what sort of outputs you have derived from the coding. So for that, the Keil software, you can change it to debug mode. That is the next mode, from editor mode to debug mode. See, in debugging, what you do is you are finding the errors. So once you go to the debug mode, you can run the simulator and test the program without actually downloading into the hardware. So how each port behaves, which pins are in one state, and which pins are in zero states. And suppose you do something related to the serial port, what is the output expected in a serial port? Those things you can simulate in the debug mode. So this is also available as a part of the Keil software. So if you use some other software other than Keil, you need a separate software for assembling and compiling. Then for simulation, it becomes necessary that you use the Keil debugger. Each system finds a lot of applications in consumer electronics, then automobile industry, industrial automation, then medical devices. If you see consumer electronics, most of the televisions of these days happens to be smart TVs, in smartphones, digital cameras. So all these things use the embedded system, and many of the modern vehicles of these days use embedded system for their engine control, then safety systems like ABS and air brakes, and many more. In industrial automation, if you see the control system, they are all done with embedded processors. The embedded processors are used in industrial machines and robots for automation, then monitoring and control purposes. In medical side, if you see, many medical devices such as pacemaker, insulin pumps, MRI machines all rely upon embedded systems. As soon as you open the Microvision, you should select create new project. Then you should give the name of the project. Here it is blinking. In the next step, you need to search, wherein you select the device for the target one. So I am searching it as AT89C51. So here we are selecting the device. When it is asking whether to copy the startup code, there you give no. Next, you create a blank text file. So in this location, you are going to type the code. It generally starts with #include the header file reg51.h. So for all the programs, this will be the first line, and then for any program you need to have void main. So it is a compulsory function. If there is only one function in the code, in a code, it is going to be the main function. So we start the code with void main. So next step, we are declaring port 1. For port 1, we are giving it as P1 is equal to 0. So that means the entire port 1, we are making it as 0, that is off state. Then we are declaring a while statement, while 1. While 1 means the entire loop will get continuously executed without any halt. Whatever code is within the while statement, that will be executed without any interruption. So it is a never ending loop. So inside the loop, once again we write P1 is equal to 0, 0, and then we are writing P1 is equal to FF. That means 1. All the pins of P1 we are making it as 1. So next step, we are going to save this file as blinking.c. The file name is blinking.c. So once the file is saved, you can see there is a color change in the code. Now this blinking.c we are going to add to the project source group 1. So now this file is added to project source group 1. So next we define the options for target 1. So I am defining the clock frequency as 11.065 and create hex file. That option is also enabled. So now we go for the build process. So when you build, you should get 0 errors and 0 warnings. Next we go for the debug. So this project is using port 1. So port 1 is displayed in the debug mode, and then we are running the code. So here you can see that the port 1 there is a blink. So in the same code you can add delays if necessary. You can add delays. So now we are going back to the program mode. From the debug mode we are jumping back to the programming mode. So this way we have created a simple blinking code. Blinking code in the sense a code for just blinking the port 1. So again the same code we are going to modify. We are going to modify by adding some more features. Some more features in the sense I am going to add a time delay so that each of the outputs, say 0 or 1, returned in the particular port P1 is maintained for some time duration. So here I am using 65,535. So until I reaches this value, this loop will get executed. This for loop will keep on executing from 0 up to 65535. So this is the delay. So the same delay I am introducing once again. For the one state also I have introduced that delay. So once again I am saving the code. So now once again we are executing it. So now the same program is executed with delay. So each time the 1 or 0 is returned to the port and there is a small delay for the next state. So this is the basic way how to write a code in Keil and how to simulate it and see the output in the port peripherals. So the same procedure you can follow for other codings also.